All right, let's go through and see where you had questions. Now, this is a root. I already found you your root. You realize you can't factor this. So what's different from last week is last week you could tell everything about it. As with this week, I have 3 zeros. I'm going to have 2 turns, 1 inflection point. Then we set it equal to 0, and we found your roots. We knew that this was odd and positive, so down, up. We know where our end behavior is. Now remember last week how you were able to graph this, how you were able to sketch it? You found your zeros. You set this equal to 0, and you factored. You put your zeros there. You knew which one was a double, which one went through. Now the problem here is we cannot factor this. So we're going to use synthetic division to pull out the rest of your zeros, because they're going to be imaginary, or they're going to be irrational, or they could also be rational depending on how many there were. So the first thing we do is we pull everything out. Take out your coefficients and list your coefficients. Follow your pattern. You add down, you multiply diagonal. Anybody struggling with this part, with the synthetic division? Everybody okay with the synthetic division? I think it's fairly nice. Now, this is what you say to yourself. If you found 1 and you needed to find 3, how many are left to find? 2. So therefore, this is an x squared, right? Because then I need to find 2. So the same thing as if I divide it out by this. If I divided by that, and actually it was probably 2x minus 1, but we can leave it like that. If I divided by that, there's the x that I'm taking away. So I'm left with this, and I see if I can factor this. So I come over, set this to 0, divide by 2, make your life easy, and factor it. And here are all your real zeros. Now, this one was nice because you can see it in your table. If not, go to second calc, do a value 2, see if y is 0. That's another way to look at it. And when you have an irrational one, that might be the way to go. Could everybody find this? This is a little different. The only different from this, from last week, was that these couldn't be factored. Everything else is the same. And today, what we're going to do is put this all back together. We're going to have you go look at your graph again, your maximums, your minimums, do your sketch, do everything else. But when it comes to finding your zeros, you're going to have to do this pattern. Okay? So that you can see it is everything we've been doing. All right, this one also, the highest exponent is 3. 3 roots, 2 turns, 1 inflection. Your end results down and up to the right. And behavior. So you try to factor, and you can't. So you look at your graph, and you find one of your zeros, and I gave you the real 0 here. So you divide this out. Pull out your coefficients. This has to become a 0, because you know that is a root. If that doesn't become a 0, you did something wrong. Don't go any further, because it's not going to work. Now, once we get to here, since we found 1, we had 3, we're now going to have to find 2 more. That's the exponent of 2. We took 1x out of the mix. We have 2 x's to find out. So bring it up here, pull out a common factor, and factor this for me. Can everybody factor that?
That's great. You factored off of 16.
Say that again? What? That was 3. I took out the 3.
I found 1, 3. We factored 4x minus 1.
1 and 3 have to multiply back to 3.
Oh, I thought I had 16.
No, 16 are your front ones. 4 times 4, this is your front one.
We have to do that.
Do you have to do that? Did you get the right factors, the right roots? Algebraically? Not in your calculator. So how'd you find it? Quadratic formula? Sure, you can do the quadratic formula on that. But you cannot go to your calculator and do a zeros and give me that. Granted, these were fractions and they're terminating, you would be okay. But if they weren't, you would be in trouble. Or if they were a radical, you can't get back to a radical. If we want to see this algebraically, you could take this original one, you could use your quadratic on that. I would get rid of a common factor. That looks a lot easier. Let's walk through A times C. You have to be able to factor. Here's what I need to factor. A times C says, I want to replace this middle part with what it used to be before I combined it. Then I'm going to group those pieces. So this is your A times C. Easiest way to go. You could do it on this one. The numbers will just be very large, but it's very doable. Now, can you find me factors of 48 that add up to 16? And add up to negative 16. I'm sorry, say it again. 12, 12 and 4. Now, 12 times 4 gives me 48. And they add up to positive, so we'll have to make both of these a negative. Agree? Good. That was very good, Kyle. So we're going to replace this with this. That's what added up to the 16x. So now, it doesn't matter what order you put them in. Group. Group this guy first. What can we factor out of here? 4x. And what's left? 4x minus 3. Now, I need this next group to factor out something so that I'll be left with this. The first thing I notice is the opposite signs, right? The numbers are the same, but the opposite signs. So what can I factor out? Negative 1. Now, this is your common factor. Take that out. And this is your other factor, 4x minus 1. You should be able to factor these. You can always resort to your quadratic formula. Okay? Those are your factors. Set them equal to 0, and you will find your 3. You expected 3. Your 3 real zeros. You can check them on your calculator. Remember, if you want to check them, go to second calc when you're at your graph. Number 1, value. Put in an x of 1/2. Oh, sorry, not 1/2, 1/4. And when you hit enter, what should your y say? 0. It's your zeros, right? It's sitting right on your x-axis. If it confirms that it's a 0, you found your root. You're not going to find it in your table because your table is probably incremented by 1s. You can change your increment to 0.25 if you want to see it in your table. But I would just do the second calc and check it there. I need everybody to be able to get this. Yes? We did amazingly well last week with this. All I'm doing is changing one thing on you. Now, here, how many roots? We did this one in class, right? Right. So just to go back over this, we expected 4 zeros. And we expected the end behaviors to go up. Now, when you factor out one of your roots, it's going to come down to a z cubed. I still can't use my quadratic formula on a z cubed. I need to have a z squared for my quadratics. So I factor out another 0 that I found. Factor the first time, the second time. This still has to be 0. When we get to this point, these are your imaginary roots. And we're not really going to deal with your imaginary roots. We're just going to say that this only has 2 real zeros. You can kind of see it curve. These are the ones that we're interested in, the real ones. Wherever is imaginary, we cannot find that on your graph because we'll need to put it on an imaginary axis to do that. So we're not going to deal with your imaginaries. We're just going to say we have 2 real zeros. Okay? All right? How many zeros did you expect for this guy? 4. Where do you expect your end behaviors to go? Up. Okay, 3 terms, 2 inflections, end behaviors up. Now, normally we set it equal to 0, we factor, but we can't factor this guy. So we say, okay, find me 1 in my calculator. And there's 2 of them, because what's going to happen is, when you get to a y cubed, you still can't factor it. You're going to go to a y squared. So you're going to have to do this twice. Right? Just like the last one we did yesterday. When you get down to this point, I wouldn't come out here and do this. I wouldn't waste my time doing this way, because then you're just going to have to take them back out again. Because you can see, we can't factor it with the cube. So find another 0 in the mix. You'll find it. I won't give you one where you can't find it, because you'd be stuck. So would I. So find it. So now we're going to take this guy out. This still has to become 0. Now this is manageable. Whether this is factorable or not, quadratic or factors, it's still doable because it's a quadratic. The highest exponent is 2. And this was factorable. When you factor this guy, watch. Normally you like to look at it like this, don't you? Where the 2 is on the other side. It's the same process. This time this is 1. These factors are prime. So 1 can only go like this. It's got to have a negative sign. So it's not going to matter where you put your 2 or your 1. They're both the same. So 2x, 1x, or x, 2x. Okay? There's your other factors. So you have, in fact, 4 zeros. How come I'm listing this one, this one, this one, and this one, but I only list 3? One's a double. Good. 1 appears twice. One's a double. When you graph this, what should happen when x is 1? Should it go through the axis or bounce off? It should bounce off. And you should see that when you graph it. Good? Some of you are missing a lot of work in there. Talk to me. Are you seeing this? Not seeing it? This is the next step to that whole big long thing that we've been doing. Okay? And for the next one, how many roots do we expect out of this? 4. Where's our end behavior going to go? Up. Okay? So we're making connections. Saying, okay, I expect 4. I look in my calculator, which means I have to find 2 if I need to get it down to an x squared. So I find 2. It doesn't matter which way you divide. I think someone asked that yesterday too. It doesn't matter which one you divide first. It'll all work out in the end. So you divide out your -3, divide out your 4. Remember, these have to be zeros. And now you're left with, you found 1, another one, you took 2 away. You're left with an x squared. And that's factorable. If you need to, do the a times c on that. So you factor that.
You can't do like ms to add to 4 but then multiply -1. Like what you could factor it like that, like when you like
Which one? This one?
no the 4x squared plus 4 times squared.
Okay. And say that again.
Can't you like isn't there like that like to like factor it you like it has to add to the middle term but
It has to add to the middle term. But be careful because this is not 1.
oh, it has to be a 1.
This has to be a 1 if that rule is going to work by itself. So what happens is this. You technically, watch how easy you can get this stuff. This factors to 1 and 3. So there's no other factors for that guy. Your signs say 1 is going to be a negative, 1 is going to be a positive. So I'm just going to put it out there right now. This factors to 1 and 4 or 2 and 2. So all I have to do is this. If I'm guessing, I could put out my 1x, my 4x. Try that. See if my middle term comes out to be 4x. If it doesn't come out to be 4x, I change these two. Put it 4, then 1. If that doesn't work, I say, okay, put it 2 and 2. That one happens to work because this is 6x minus 2x. There's my 4 in the middle. It only took me 3 tries to get there because this out here was a prime. This out here can only go one way, 1 and 3. And they only had 2 factors of this, so worst case scenario, it took me 3 tries to get there. But when A is not 1, you can't just go by the middle number.
So when does multiplying the A and the C term apply?
Absolutely anytime you like.
So you can
Multiply A times C. What's 4 times negative 3? You can always do this. Negative 12. What are factors of negative 12 that add up to 4?
6
And negative 2. Plop your x's. Now replace this. 4x squared plus 6x minus 2x minus 3. Group. What can you factor out? 2x, and what's left? 2x plus 3. Okay. Now, what can I factor out of here? I have the same numbers, but look, they're the opposite signs.
So the -1.
Negative 1. Now, here's your common factor. Here's your factor that's left. Absolutely. A times C always works. A times C even works when this is 1. Yeah, it always works. That grouping always works. If you're like hesitant at all about trying the other way, do the A times C. Yeah, A times C. I don't really like, at this point, if you can't factor, I don't like to throw the tricks in there. Some people double the first one, then take it out later. I don't really like those if you're still struggling with factoring. I'd rather just go to one routine. It always works, A times C. Alright? So we found that that had 4 roots. Okay, this one, I expected to find 3. So if I find one real one, it'll bring me down to a 2 squared, which I can then factor. It may not be pretty. This is not pretty. I can't make a factor, and I can't find factors in this because I don't have factors of 1 that add up to 4. So I have to use my quadratic formula for this. This you have to use your quadratic formula. Or you can complete the square. Anybody complete the square? You can complete the square for this as well. This one's not a bad one because A is 1. And you need to find 3 roots. So this is my 1, and these are my 2, plus or minus. When you check this in your calculator, do second calc, value 1, and put in one of these conjugates, 2 plus radical 3. The y has to say 0. If one of the conjugate pairs works, the other automatically works. Because you find your conjugates whenever you do your quadratic formula. I think these were even easier than the ones to the 4th power. So if the last one is to the 5th, and you can factor someone that's a square, how many did you have to find? 3. You had 5. You can factor a square. So Kyle said you got to find 3. So we were able to find 3 factors. 0, 0 is a factor. And you can divide by the 0 as well. At this point when we got down here, this wasn't so bad. We factored out an x over here. Everybody contained an x. So factor out the x first. Do you see what I did, guys? I factored out the x first. You can factor out a 0 and then just use the plus 0 routine. But factor out this x and take care of that guy. That's 1. Then I factored from this a 3 and a 4. And we were left with this one. we can't factor this, so we set this equal to 2. Take the square root, and x is plus or minus. So that gives you your 5 roots. Where's your end behaviors going? Up, down, up on the right, down on the left. Good. Questions? No? Everybody can do this? Okay. So when you come to this first one, remember how we did this? All I want are your factors left. We have time. Let's do the first one together. Okay, we'll do one of each of these types together. So think back. These are your zeros. I need to make an equation. And you can leave it in factored form. So how do I make this x equals -2 into a factor? X plus 2. Set it equal to 0, remember? So add 2 to both sides. There's my factor. How about this one? X minus 3. There's my factor. Remember? Remember doing this? Right? Because if you set them equal to 0, wouldn't you find your roots? We're just kind of working backwards. Now, we need to work with this one. We did this again yesterday. How did we find a quadratic that had those roots that were irrational roots? How did we find it? No, we did it by the sum and the product. Sum, product. Because it's going to fit this format. Right? So let's take the sum of those two. What's the sum of 2 plus radical 3 plus 2 minus radical 3? 4. This is equal to negative b over a. And we said, all right, let's get a out of the mix here. What's b? Negative 4. Good. Then we took the product. Okay, because they're perfect squares, we can multiply the first terms and the last. So 4, and you could actually do these both on your calculator, because they have to come out to be real numbers, real rational numbers. This would be negative 3. So what's your product? 1. C over A. We took A out, so what's C? 1. So all we have to do is put that back into our quadratic. Oops. Minus 4x plus 1. Put that right here. That's my equation. And you don't have to FOIL anything out. You can leave it in factored form. Because what would happen is you would have to keep dividing it out, finding your real zeros, and then the last part when you're left with your quadratic, put it in your quadratic formula. You just work it backwards, right? Aaron, you see me right through those lids? Aaron's shaking his head while his eyes are closed. Yeah, you can hear my voice, right? Okay, now, for these guys, we're going to go back through this whole thing. We're going to sketch maximums, minimums. We're going to do the whole thing.
You said some of your quiz something. Didn't even go to 11:06. Remember? You said quiz that.
Yeah, but I added in your zeros to this.
So we have to do all that for the quiz plus this.
Yeah, we made that grow. We added on to this.
From that.
Yes. That's going to keep growing. All this knowledge that you have just keeps growing. You keep adding all these good points to this. So, describe me this graph. What do you know about this graph? 3 roots.
Nobody got
Daniel knows 3 roots. Where's my end behavior going to go? Up on the right, down on the left, up on the right. So normally we take this and we set that equal to 0 and we try to find our zeros. Well, yeah, we're allowed to, but can you factor this? Can't factor that one. We can factor the x squares, but not an x cubed.
Can't you do partial fraction?
Well, you could try a grouping and see if we can factor it that way, but it's not going to work out for that.
It's just like
So let's plug it in your calculator and tell me what your 0 is that you can see. Give me one real 0. I should have 3. All I need to start with is 1. Everybody find one for me? 1? Everybody get x equals 1? Okay. You have a graph that kind of looks like this. It goes up. You're going to have to sketch. Yes, we're going to sketch. It looks like this. And we should be able to find one of your real zeros when you go. So 1 0 is right here. One of our zeros is 1. So let's do your synthetic division and see what's left. So let's pull out your coefficients. 1, 4, -4, -1. Let me check. 3, 2, 1, 0. So down first, bring it down. Multiply diagonally, add it down. Multiply diagonally, add it down. Multiply diagonally, and this better come out to 0, right? Because we knew that was a root. We found it. How many roots do we have left to find? 2. So x squared plus 5x plus 1. Can I factor that? If I could try, do I have factors of 1 that add up to 5? Nope. And Alex said, I got to use the quadratic formula. I could complete the square on this, but this is a half, so I wouldn't. So A is 1, B is 5, C is 1. And you're going to do that. Now, you're also going to have to, on your calculator, go back and find me a maximum. Is this a relative maximum or an absolute maximum? Relative. Is this a relative min or an absolute min? Relative min. You're also going to find me concavity, so I have to find, what is this guy called in here? Inflection point. I add my x's and take the average, divide by 2, find my inflection. I want increasing, decreasing. What's the domain for this guy? All real numbers. What's the range? All real numbers. And so then you're going to find me the rest. The maximums, the minimums, the increasing, the decreasing, and your inflection points.
so reducing the x squared plus 5x.
Well, no, you got to put it into your quadratic.
Oh, okay. It says all real or just everything.
If it's imaginary, you wouldn't be able to see across that axis. These are all real.
Like I'm